Hello everyone, welcome back. This is N3FJZ with more ZX front panel work. Okay, I have my Stockton bridge assembled and I actually have it in the circuit now. And I have the forward and reverse or reflected sensor wires connected. Here I just simply used a twisted pair, ground at the other end and just wrapped it around just to give me some shielding. Probably in the finished product or the finished build I may use coax, small coax cable perhaps. Well, what I got here is I have the code now completed for the what I call the tune screen. And this takes the place of the SWR meter I had connected in line. So we just put this module in place of where I had the SWR power meter. And it's being a Stockton bridge, it's a I guess you call it a flow through design. On the left is the transmitter, goes in on the left, antenna on the right. Okay, then when you get to the tune screen here, and I haven't fully calibrated this yet, and the SWR bar graph doesn't actually do a calculation. I may have it wired in, but it's not actually wired in or in the code to use the calculation of the forward and reverse. And you'll see there that I had to change the tick marks in the label designations to a non-linear scale, because that's the output of that Stockton bridge isn't linear. And what I found was I wanted to keep the forward and reverse watt bar graphs in the same magnitude. So it's 0 watts on the left to 50 on the right. But what I found in practice is that when you're trying to tune your antenna tuner, on the reverse or reflected watts, it would get down below 0 and there'd be no bars showing if you wanted to fine tune. So what I have, and you can see this little extra bar box, and I'll demonstrate how that works. So as this thing approaches 0, very low value wattage, that last segment on the left in the main bar will go out. However, you still may have a few millivolts on the Arduino pin, and that little box underneath the word REV is sort of an extended scale on the 0 end of that bar. So, and the way you would use this tune screen is when you go from the main screen and you hit the function select button, you'll get the tune screen. And what the tune screen will do will also assert a pin that will, Arduino pin, that will throw a relay on the balance modulator to unbalance that modulator. And what that will do is that when you hit the push to talk button, it will output a continuous wave from the PA so that you can tune. And so, with that being said, okay, there's my push to talk toggle switch. So now I'm in transmit, however I have the actual power turned down. So the way this would work is, well, first let me identify here. N3FJZ testing. Okay. Bring the power up. I'll bring up the 5 watts here. And if you'll see, the small bar is actually toggling around a little bit. And you can see what it does here. As you're tuning, if you want to get exquisitely fine tuning to get the lowest possible reflected. And I'm turning, you can't see this, but I'm turning the capacitor to the balance tuner, and you get down towards that 0 mark, and then of course the little bar graph will give you like a sub millivolt or subvolts range, where you could try to get that as low as possible. So it would probably be the best tuning for that. So there it is. And I was just racking my brain on how to, I was going to say, do I need to put like multiple scales, and how would I switch between them? And it kind of just dawned on me, it's like, well, a little extended scale bar graph on the left side there, just to give us some fine control. You try to get that as low as possible. So there it is. And of course the upper scale, and I got to calibrate this better because I think there, right there is 50 watts, and you can see it's at 35, so I got to do a little more calibrating on that. Okay, 7.3 everyone, N3 FJZ.